Have you ever wondered how computer programs are created? It's not magic, nor is it something only geniuses can do. It's called programming. Like learning a new language or mastering a musical instrument, programming is a skill that can be honed with practice, patience, and a touch of creativity. In the upcoming minutes, we'll be exploring the fascinating world of programming. We'll start by defining what programming is and why it's so crucial in today's digital world. We'll touch on the different programming languages out there, each with its unique syntax and use cases. We'll also delve into key programming concepts such as variables, data types, control structures, and much more. We'll guide you through writing a simple program, and we'll show you how programmers solve problems and debug their code. And finally, we'll provide you with resources that will aid your learning journey. So buckle up and let's dive into what programming is all about. So, what exactly is programming? Well, it's like teaching a computer to perform tasks. Programming, also known as coding or software development, is the process of creating a set of instructions that a computer can execute. These instructions are written using specific languages, called programming languages. Think of it like a recipe. You list out the ingredients and steps so that the computer can cook and serve the desired result. But why do we program? Programs are created to solve problems, automate tasks, manipulate data, and perform various functions on a computer or other electronic device. From the apps on your phone to the software on your computer, programming is the backbone of these tools. It's the secret sauce behind all our digital conveniences. With this understanding, we can now explore programming languages. So stick around as we delve deeper into the world of programming. Programming languages are the tools we use to write programs. Think of them as the grammar for our coding language. This grammar in programming speak is referred to as syntax. Syntax is a set of rules and conventions that dictate how programs written in a particular language should be structured. It's like knowing where to put the verb in a sentence when you're learning a new language. There's a veritable smorgasbord of programming languages out there, each with its own unique syntax, strengths, and use cases. Some of the common ones you might have heard of include Python, known for its simplicity and wide use in data science, JavaScript, the go-to language for web development, Java, a general-purpose language with wide application, and C++, used extensively in system software, game development, and many more. Now that we've touched on programming languages, let's move on to key concepts in programming. There are several fundamental concepts in programming. One of these is the idea of variables. Variables are like containers for storing data values. Each variable has a name and a type. For instance, it could hold an integer or a string, which are examples of data types. Speaking of data types, these are different kinds of data that can be manipulated in a program. Some common data types include integers, floating point numbers, and strings. Understanding data types is crucial as they determine what operations can be performed on the data. Next, we have control structures. These are constructs that manage the flow of a program. You might have heard of loops like for or while loops, or conditional statements like if and else. These are all examples of control structures. They help us repeat certain actions or make decisions in our code. Now let's talk about functions or methods. These are blocks of reusable code designed to perform a specific task. Functions can take parameters, which are inputs that can change each time the function is called. They can also return values, which are the results of the function's operations. Another key concept in programming is the idea of objects and classes, especially in object-oriented programming. Objects represent instances of classes. A class is like a blueprint that defines the attributes and behaviors of its objects. Now that we've covered these key concepts, let's briefly touch on writing a simple program. This process involves an algorithm, which is a step-by-step procedure or formula for solving a problem. Here's an example in Python. Imagine a program that simply prints "Hello World" to the screen. It would look like this: print "Hello World." Programming involves translating these kinds of algorithms into code, using the concepts we've just discussed. These concepts provide the foundation for writing programs. Now let's look at problem solving. Programming often requires a problem-solving mindset. This journey involves two key techniques: decomposition and pattern recognition. Decomposition is the process of breaking a problem down into smaller, more manageable parts. This is akin to slicing a large pizza into individual pieces. It's easier to tackle one slice at a time, isn't it? Pattern recognition, on the other hand, is about finding common threads or sequences that can be applied to solve problems more efficiently. For instance, if you've figured out how to add toppings to one pizza slice, you can apply the same process to all the others. Beyond these, there's the essential task of debugging and testing. Debugging is like playing detective. It involves identifying and fixing errors or bugs in the code. Testing, meanwhile, ensures that your program behaves as expected, like making sure each pizza slice is perfectly baked and delicious. This brings us to the conclusion of our journey. As we wrap up, remember there are many resources available for learning programming. One such resource is version control systems, or VCS, like Git. These tools help you keep track of changes in your code, collaborate with others, and revert to previous versions when needed. Also, understanding the software development lifecycle, or SDLC, which includes planning, analysis, design, implementation, testing, deployment, and maintenance, can greatly enhance your programming skills. In addition to these, there are numerous online platforms such as Codecademy, Udacity, and Coursera that offer interactive programming courses. Books and official language documentation can also be valuable resources when you're diving deeper into a specific language or concept. Lastly, participating in community forums can provide a wealth of collective knowledge and experience, helping you overcome challenges and continue to grow. That's all for today. Stay curious and keep exploring the world of programming.